Okay, so 我们今天要来看的是关于到 alkene 的部分 ，alkene 的 introduction。Okay, the difference between alkene and alkane，它其实第一个部分就是关于到它的 formula itself. So if we look，我们这里其实是 CnH2n。Okay, it's different from alkane. Alkane 的话，它好像我有记错，好像是有 +2 在后面的。Okay, so this is let's see. HN H2n plus 2，这个是 alkane，然后 alkene 它是 CnH2n。那 the only thing 他们这两个会有一个共同点是在他们如果 alkane 是 cycle alkanes 的时候啊，他们才会有一样。OK， 这是 formula 是完全一样的。Except for that，他们的 alkene 其实是不一样。And plus there's another difference is that there is a double carbon bond. OK， 那如果是这样子的 carbon-carbon double bond 的时候，我们就会讲它是 unsaturated. So you can see that it's given that it's unsaturated, you cannot have it will contain double bonding and also made up of hydrogen and carbon atoms only. 这个就是我们的unhydrated 的一个 group. In terms of the naming， 我们会加 ENE. Okay, for in terms of the alkene family. So let's have a look. 这里是我们所有的 listing of all alkenes. So you can see that's all double bond, double bond, double bond. Okay, and it keeps going forward. Up and up and up. Now, in terms of the bonding in alkenes， 我们永远就是记得它的那一个 electron configuration for each of the carbon to be 1s2, 2s2, 2p2. Okay, 然后它有一个负 outer shell, etc. And in later we will introduce something that's called sigma bond and pi bond. Okay, now 什么是 sigma bond? Okay, sigma bond 它其实是一个 s bond and s bond, or maybe like one of the example is s bond and s bond overlapping. Okay, orbital s and s orbital overlapping. 那它其实是关于到 n to n overlapping of the atom orbital. Okay, we will look more of the details after. Okay, maybe we will give an example after. Okay, so for example, 最简单的例子就是我们的 hydrogen 和 hydrogen， 因为它们是 s and s， 它们就是一个 pi bond. Okay, not pi bond, sorry, sigma bond. However， 如果是 pi bond 的情况，它是 sideway 的啊，这个就是它们之间的 difference. Okay, it is sideway for pi bond. So hence, and also it's also using p orbitals. Okay, for pi bond. So 我们在这里看到的是 two of the p orbitals. 看到吗？这个里是我们的 s. Okay, maybe it's s, maybe it's not 啦。Okay, assuming it is. 这里有我们的 p orbital， 这里也是我们的 p orbital， 它们会 combine 在一起。Okay, and that's what it makes as a pi bond. Okay, so we have two electron clouds in this case. So one of the example that we can see, it's in our organic chemistry 里面的 C and C double bonding. Okay, so we can see here is a p orbital, p orbital, p orbital, p orbital. Okay, supposedly 它应该是长这个样子的。OK， 然后就像我讲的一样，因为这里是 side by side， 这里是 n by n， 所以这里就会出现一个sigma bond， 这里也会出现一个 pi bond。Now, in terms of 我们的carbon， 它其实外面的时候，也就是说这一边它也是可以继续 match 的。Okay, so hence there should exist a sigma bond outside if there is another hydrogen nuclide there. Okay, or maybe even carbon. Okay, so between carbon and carbon, they will have a sigma, and then also carbon and hydrogen, they will have a sigma. Otherwise, both the p orbitals will be in pi bond, as long as it's sideway. So these are the introduction, and let's transit to 我们的 geometric. Now, 这一个部分呢，它其实in terms of the information, it will be a lot. Okay, but slowly, if we look at more examples, it will be more fluid. So, we will look about how geometric of the isomers will look like. Okay, we will classify in terms of C and Z or cis and trans. C and Z will be the one that we introduce first, I believe. Yes, we'll introduce. Wait, actually, we'll introduce cis and trans first. Okay, so let's have a look. What are the difference between but overview first? What is the difference between E and Z 还有我们的 cis and trans? So E and Z 本身呢，它们的 difference so if I make a Venn diagram lah, okay, this is our E and Z, this is our cis and trans. So in terms of this one, 简单来讲就是 E and Z 它其实是一个 subcategory of E and Z. Okay, so you have to have a special case of the E and Z in order to have cis and trans. Okay, but in terms of cis and trans, is basically happening in a saturated compound. 然后 it is able to have a free duration due to our C and C bonding, a pi bond, a sigma bond, not pi bond. Okay, we'll look more detail after, but if it's unsaturated, it will remain as a pi bond. Okay, that's not possible. So 如果它是 C carbon double double bonding, 那然后它就会 form 一个 pi bond, so there's no free rotation. Okay, 因为它的那个 bonding 就是 lock 着它了。Okay, 它没有的就是转来转去。So that's the reason why it does not have a cis or it does not have a trans. Okay. Another thing is with the overview of cis and trans is that cis 本身 is a two functional groups. Okay, with the same sites. However, 如果是 trans 的时候，它其实是 two functional, it's true, but it must be the opposite. Okay, so for example, 如果它是same set 的情况，也就是讲这里和这里 so this is our carbon. Okay, 或者是可以是这里和这里 that's the same side. Okay, opposite side 也就是讲如果这里是我们的 carbon and carbon, let's see, you know what, let's change this to here. 然后这里是 up and down 这个样子啊，这个也是 okay, so it must be this is what we call opposite. We will look more detail after. Okay, so this is the overview of cis and trans. So 我们看到这里的它其实就是讲there is a free rotation. So 看到吗？就是 it's a free rotation around the C and C bonding. So 也就讲there are two of them that can be transited. So hence 我们可以把它变成 trans. So it transfers from here to here. Okay, 或者是 if it's in terms of cis, 这个是 in terms of trans 吗？所以我们 in terms of trans 的时候，看到吗？ opposite. But if in terms of cis 的时候，它就是 same side. Okay, that's what we always want to say about. Okay, just remember there's no possible of the two molecules to transform from one if it's C and C double bonding. Now, 我们来看一下 E and Z. So we are going back again. Okay, so before we even learn about naming ours, deducing our E and Z, so we learned about cis and trans already. What about E and Z? 当我们看到这一种之后 there are cases that cannot be have cis and trans, right? So 我们在这个时候 we have to treat it as how do I say it? It's like there's a special circumference, not circumference, like special case for it. Okay, so let's take an example. 如果 okay, 如果我选择直接去 so 我们看到这里其实是没有的嘛 okay, so we can see from here that it does not have a cis trans isomer because we can see that it has a double bonding. 可是我们可以就是 it's according to this pivot 然后他们去 rotate. However, 我们可以去做的一个东西是 move the methyl group. Okay, we can move the methyl group. So that results into from transiting to 2H on the left, 2CH3 on the right. 我们会换去，就是很像讲我直接 move 它去那一边。Okay, I move from here, I exchange here and here. I exchange, what was it again? Here and here. 这个样子 to make it to cis and trans. Okay? In fact, 这个时候就会有一个breakdown 啦 ，OK, in terms of 的这一个 butane 2 OK, 就是我们看这一个 case. However, 我们看到这里 does not, 我们看这一个 C and C bonding they do not have to be the same of the cis and trans, right? Okay, however, it does have a cis and trans. 所以就讲这它们不一定要一样的。Okay, what it means is that it does not have to be like this and this, must be the same as CH3. Okay, so we can identify that cis and trans like that. But again, there's a lot of buts in this case, so maybe pause the video and make sure to kind of like understand it. We have more examples at the later, so it will be more like easier to digest. Okay, so 我们看这里，如果我们的 naming system, okay, 我们要是有一个 naming system 的话 it will start to fail if we have more than one of the atom group, okay, on the either side. So these two are fine, but 如果是看这一个的话 it does require a new name for it. Okay, 因为我们总共有3个不同的 atom. Okay, so we must have a new system, naming system for it, and that's where we introduce E and Z isomers. So generally, 我们要看这个 E and Z 的 isomers, 我们要看的 in terms of 它的 general name is C2R4. Okay, we call it as R1, R2, R3, and R4. Like that. And we always prioritize the higher atomic number. Okay, so for example, if R1 has the highest atomic number, 我们 prioritize 它 and etc. Let's have a look. So 我们看了这一个情况 Okay, so we can actually have 2 different displayed formulae in terms of compound A and compound B. Okay, but how can I do it? So the first step, so there's the detail note. If you want, you can read the detail note while I am doing the compound. Okay, if not, you can also follow what I'm doing right now. So here's the trick for it. How do I differentiate between E and Z? Okay, so the word E, it's meaning opposite. It's coming from a German word. 然后如果是 Z, it would be the same. Okay, so what do I mean by that? Okay, so if we have to look at R1 and R3, R2 and R4 like that. So if we look between R1 and R3, which one has a higher atomic number? And this one has a higher atomic number. Okay, bromine has a higher atomic number, and also in R2 and R4, oxygen has a higher atomic number compared to carbon. Okay, so this one, when we are comparing, we look first bit by first bit like that. Okay, if we got compound or something like that, we've looked at by first bit. Now, how can I know if it's same or different? Okay, so since 我们这里 okay 看到吗？我们的这一个 higher priority, it's opposite, so hence it's E. That's it. So 我们看这里 higher priority, correct? It's the same side, so this is Z isomer. Okay, so that's how we differentiate it. Okay, so in terms of our name, 我们可以讲的是 this is E whatever thing that has written here. 然后 Z whatever name that has written here. Like that. Okay, so that's how we can differentiate between E and Z. Let's have a look again with a more complicated case. So how can I know if this is a E or Z? Okay, so again 我们要 compare 的是这一边和这一边。So if we look at R1 and R3, okay, the first attach, we always compare from the nearest to the bond. Okay, 我们不要看的是从左边开始而已，我们要看的是谁 who is the nearest with the bonding. Okay, so C and C is the same. Okay, it's fine. So we continue first. Okay, now if I compare second one, so let me use a highlighter. When I'm comparing R1 and R3, C and C is the same. Okay, done. Skip. H2 and H2 is the same. Okay, done. Skip. Now, C and BR. Okay, so C and BR, if that's the case, how can I compare it? Okay. When we look at this side, we have to look who has a higher atomic number again. Okay, so let me. So I'm using a different color to deduce where I start looking at my atomic number. Okay, so when we look at periodic table, bromine has a higher atomic number. So hence, this is what I want to focus. Okay, 这一个是我要 focus 的地方。R2 and R4. Again, let's try again. Same. Now, this one, it does look like they have a different 就是 hydrogen, 对不对? It looks like they both have hydrogen, different number. But the thing is, okay, when I'm looking at this, when I'm looking at R2 and R4, okay, I actually look at the entire thing here. H3, H2O. Like that. Okay, when it's different, 我们要看的是 entire compound like that. So, if that's the case, 我们会看到的是 hydrogen in this hydrogen does not have a higher priority. So that means we are prioritizing on 我们的 I used the wrong highlighter. I need to prioritize on this one because it has a higher atomic number from O, oxygen. So in this case, we know that this is Z because it's the same. That's how we can deduce it. Okay, so this is basically how we can differentiate or deduce between Z and E. Okay, but overall, the main part for this place is knowing how to differentiate cis and trans, and after that, maybe practicing a bit of how to name cis and trans with the organic chemistry part. That'll be it for this part.